Hi, my name is Buddy Stark. I manage the theater here at Longway Planetarium. So if you're interested in doing this yourself, or you're just kind of curious as to whether or not I did it right, we'll show you. We've got a video, and we'll put that link like here, right? We'll put it somewhere in this area in the video. Okay, so without further ado, the idea is that each one of these strings represents a certain thing. So this first string, there's a little tag. I'll bring it closer to you here in a moment. And this little tag represents the diameter of the Earth, the whole planet that we're standing on, right? And then the length of the string is, okay, so if this is the size of the Earth, how far away is Neptune? And so that's the length of the string. And then the second string, we're going to shrink this whole first string down to be just this long, right? The distance from the Sun to Neptune fits right here. And so, the distance from the Sun to Neptune is again right here, right? And then a third time like right here. And this string right here represents how far away is the closest star if this is the Sun to Neptune, right? The third string, okay, so we're going to shrink this whole second string down into this space right here. This is the distance from the Sun to Proxima Centauri, right? Then how big is our galaxy? How big is the diameter of our entire galaxy that we live in? That's the length of the third string. And finally, if we shrink our entire galaxy down to this spot right here, I've got crude drawings for each one. I'll try and show you. How big is the known universe? How big is the universe that we have visibly seen so far? All right, so that's what we're doing. Okay, so the first one, hopefully this goes well, is again this little thing right here. Hopefully you can I have a crude drawing, that's just kind of a circle. That's the diameter of the Earth. And so this string represents, I'm going to keep pulling, the distance out to Neptune. Okay, so we just realized the gravitas of the situation. We're going to have to speed it up, there's just no way. You're going to watch a time lapse regardless. All right. Okay, is this one still filming out here?
That's what I'm about to go check. Yeah, you don't have much time left though.
Okay, all right, so that's the first string. There's going to be multiple shoots as it turns out. So, the length of this string, I wrapped these all myself, but I did it over the course of several days. And even doing the math, I didn't appreciate just exactly how far away Neptune is from the Sun until you pull over a mile's worth of string. So if this is the size of the Earth, then the pile of massive string beneath you here is the true distance to Neptune. Next, which we're going to have to switch out SD cards for because we're just filling up the memory too fast, is going to be out to how far away is the nearest star. We're going to take this entire string, this whole big bundle you just watched me pull, and we're going to shrink all of this down to just this distance. So each time we pull another 10 centimeters of this string, it's going to represent the full length of this string each and every time. All right, here we go. And this new string represents the distance from the Sun to the next closest star, which is Proxima Centauri. Aha! All right, so here's the end of the string. And again, so this tag here is the distance of the Sun to Neptune. And this particular string, this bundle that we just pulled, is the distance to the next closest star. And of course, there are plenty of stars much further away. We'll see those with the next string. Here we go. So now we've taken that entire string, that whole big second string we just pulled, and every one of these distances on this new string represents that same string. So here's that string a second time, and a third time, and a fourth time. And so you can see these distances are getting huge. This third string represents the size of the galaxy that you live in. Oh, aha. All right. So, once again, this here is the distance from the Sun to the closest star, and this string that we just unraveled here, which is now a mess like all my other strings, is the size, the diameter of the Milky Way galaxy. All right, on to the fourth string. The fourth string now, so we're going to take that third string, which is the size of the galaxy, right? We're going to shrink it down to be one of the smallest of my tags here. I've drawn a crude Milky Way onto the little tag there. So that now, that whole string, every time we pull half a centimeter here on this new string, that's another one of our galaxies, right? So you can see this is going to add up very quickly. I'm up to like 6 or 7 galaxies worth of distance here, right? And so this new string represents the size of the visible universe, everything that we've seen with all of our modern telescopes, something like 90 billion light years across. All right, and there you have it, hand over hand, the size of the universe if the Milky Way was about 5 millimeters across. I'm not going to bother finding that tag. Keep in mind this demonstration is very one-dimensional, right? The universe really is this big, at least three-dimensional thing around us, right? And so this kind of distance is in every possible direction. So very cool. Hopefully you found this fascinating. Hopefully you kind of have a good perspective on, at least as best we can, the size of the universe. If you have your own activities, your own ways of demonstrating the size of the universe, please let me know. We'd love to hear them. We are always looking for more activities like this. And thanks for watching.